Good morning, everyone. Welcome to today's presentation on the fundamental of computer networks. My name is Rahat Khandaker Neloy, and we will be exploring what networks are, how they work, and why they are so essential in our digital network. I'm the student of Southeast University, Department of Computer Science and Engineering. So let's start with learning objective. By the end of the session, you'll be able to define what a computer is and discuss the advantages and disadvantages of computer network and describe the main types of computer networks and finally describe the main type of computer networks. Then computer networks. Let's start with the basic. Simply put, a computer network is two or more computing devices connected together to share resource. And a computer is two or more connected and resource. Whether a computer that is not connected to a network is stand-alone. A device is not connected to a network is known as stand-alone machine. It's important to remember that the term computer now encompasses a wide range of devices, including our laptop, tablets, and smartphone. Next part is advantage of networking. So why do we connect this device? Network offers several powerful advantages. This advantage is files are stored centrally on a several servers so can be accessed on computer across the network. On the internet connection can be used for multiple different devices using a router device. Printer scanner are accessible on any network connected computer. User connect and software can be developed across the network computers. IT simply management IT administration can develop software and manage user accounts across the entire network from a central point. Cost efficiency multiple devices can share a single internet connection via a router and expensive hardware like printer can be shared. Centralized storage means files are stored on a central server, making them accessible from any computer on the network. The other side is the disadvantage of network. The availability, performance, and management are some disadvantages of networking. However, network also comes with one set of challenges, which primarily revolve around three areas: availability, performance, and management. Availability: if connection is lost, files and devices are unable. The network itself becomes a single point of failure. If the connection lost, access files and device is lost with it. Performance: larger networks are slower and less reliable. Explained it as more devices are added, network can become slower and less reliable due to conjunctions. The third is management. Specialized knowledge and skills are required. Setting up and maintaining a network requires specialists knowing and skill adding to complexity and cost. Network types of network. There are three types of network: PAN, LAN, and WAN. PAN explain is personal area network, LAN is local area network, and WAN is wide area network. Personal area network PAN. A PAN or personal network revolves around the individual person. Is a very short range of network, typically up to 10 meters, often using Bluetooth technology. Common example including the connection between your smartphone and your wireless headphone smartphone of car's entertainment system. Pen, the some example of pens are smart watch, wireless headphone, wireless keyboard, mice and car entertainment system. Then are local area network LAN. Local area network is used within a small geographical area which is usually limited to one building. That is, enter the whole building is covered with land. This network can connect it wirelessly, but for reliable wired hardware, Ethernet is often used. Some example of LAN is home networks, some small business, school, and college. Your home is Wi-Fi is classic example of LAN. For speed and reliable, a wired connection is used that called Ethernet. Third is wide area networks. Wide area networks one is paired across a large geographical area, often an entire country or further. The Internet is a large-scale one which uses undersea cable to connect computers across the world. The one is used. The most famous example of one is Internet itself, which use a vast infrastructure of undersea cable and satellite to connect us all. Other example includes mobile networks and international banking networks. The sum is example of pen, LAN, and one. So let's can drag and drop the network example into the correct categories. Pen is smartphone, headphone, in-car system. LAN is home network, office network, school network. One example: the internet, mobile networks, bank networks. The next topic is TCP and IP model. The introduction of TCP and IP model. Now, for this device to communicate, they need to speak the same language. This is governed by rules called protocol, which are organized into the layered model known as TCP and IP model. So let's start learning objective. In the TCP and IP model, we can learn describe the four-layer TCP and IP model, describe the function of each layer in a network, understand the protocols that operate on each layer. A protocol is simply set of rules and communication. The TCP and IP model stack these protocols into four distinct layers, each with a specific job. From the top down, these are application, transport, internet, and link. Application, transport, internet, link. Protocols means rules that defines how devices will communicate with each other. The internet uses a series of different protocols. These protocols are organized into a stack. This is called TCP and IP model and has four layers that set up adopt another. The layer of protocols exist for each device that is communicating. The first layer is application layer. The application layer is further using um, application like web browser and email client operate. These layers are specific protocols to request data. For example, your browser uses HTTP and HTTPS to request a web page, and your email client uses SMTP to some mail or IMAP to retrieve it. This highest layer of TCP and IP model is where the application side, the application sent the received data that is then sent into the rest of the protocol stack. The application layer adds header data that can be stacked through the stack. Various type of protocols sit on the application layer depending on the types of application being used. There are some example of protocols is HTTP, HTTPS, SMTP, IMAP, FTP. The second layer is transport layer. The data from application layer is passed down the transport layer and the layer jobs is break the data into the manageable packets, number of them simply and at ports number. It has two key protocols, TCP, which is reliable and recent lost packet, and UDP, which is the faster but does not granted delivery, making it ideal for live streaming or gaming. The source and destination port are added to the header. Each packet of data is given a sequence number so that it can be reassembled. Transmission Control Protocol (TCP). TCP is reliable transport protocols because it will always request again any missing data packets. User Data Programmable (UDP). UDP is a faster transport protocol, but this makes it unreliable because missing data packets are discarded. The third layer is Internet. The Internet layer. The Internet layer is the post office of the network. In address is packet with a source of destination IP address and is responsible for routing, finding the best path across the network to deliver the packet to its final destination. The Internet layer routes packets of data from device another across the network. Each device is assigned a unique IP. IP full form is Internet Protocol. Unique IP address, which identify the source and destination for data packets. The Internet layer is whether the best route is determined for the data packet to get from its source IP address to its destination. The fourth layer is link. The link layer encompasses the protocol of different communicating technologies. Finally, the link layer deals the physical connection. It encompasses the hardware and the protocol that control how data is transmitted over the physical medium, whether it were Ethernet, Wi-Fi, fiber optics, or a cellular 4G connection. This link layer is most common. This protocol is Ethernet, which is used in local area networks. The protocol determines how packets of data are transmitted between devices. There are a variety of different links layer protocols, some wired and other wireless. There are some examples of link layers protocols that are Ethernet, Wi-Fi, fiber, 4G, and satellite. The next topic is the next topic. Not briefly describe the function of each layer of the TCP and IP model: application layer, transport layer, internet layer, link layer. So we can write the function of each layer of the TCP and IP model. Application layer. To recap, the application layer tells the software. The transport layer manages the data flow. The internet layer handles the addressing and routing. The link layer deals with the physical hardware. The layered approach is what makes modern networking possible. Application layer common operating the application communication with the TCP IP stack. For example, the web browser or email client. Different applications use their own protocols. Transport layer breaks down the data into packets to be transferred. Packets are smaller than the original data, which makes them easier and quicker to transport across a network. The third is Internet layer routes packets of data across the network to the correct destination based on its IP address. The Internet layer determines the most effective routes to send the packet. The last layer is link layer, operates the hardware protocols that are used by each device on the network. So you can list link layer is three. There are a variety of different link layer protocols, some wired and other wireless. Some examples are wired and some are wireless. Link layer is connection or mixing and some wired and wireless. The next topic is network topologies. Which is topologies. We will not look at the two most common LAN topologies, bus and star. We will describe their difference and discuss which is more appreciated for a given scenario. So let's start. Network topologies. Learning objective. Describe common LAN topologies, bus and star. Describe the difference between the two topologies. And there are bus and star. Select the most appropriate topologies for a given scenario. Network topologies. A computer network is two or more computers connected together. Rather, a computer that is not connected to the network is standalone. The way in which computers on a network are connected and organized is called topologies. There are two main topologies and bus and star. Bus topology means in a bus topology, every device is connected to a single central cable called backbone or trunk. We can call it a backbone or trunk. Data is sent up down is this cable, and each device listen for data addressed to it. It is simple and cheap to install. All data is sent up and down this until and reached connect device. It is very cheap to use bus topology. So there are most of the people use bus topology, and the office and company are use bus topology for their reliable source and low cost. Uh, so they use bus topologies. Star topologies. In a star topologies, all devices are connected as centralized device, like a switch or a router. All communication passes through the central point. This is the most common topology found in modern home or office network. Every office and networks are use star topology because star topology is easier and connect easily. Network devices are connected indirectly through a centralized device called switch. This switch is mainly important for star topologies. This can be a dedicated device or built into a router on home networks. So you can see the difference of bus topologies and star topologies. The slot the character is into the connect network topologies. Yes, some examples uses a centralized switch, use expensive equipment, use a backbone cable, more reliable and efficient, cheap and easy to set, not reliable at large scale, use for home network. So let's start and separate the bus topologies and star topologies in their categories. Bus topologies uses a backbone cable, um, cheap and easier to set up, not reliable at large scale. Star topologies uses a centralized switch, use expensive equipment. Star topologies are makes for expensive equipment, more reliable and efficient. Use for home networks. The next topic is network hardware and software. So network hardware is making these topologies work requires specific hardware. Let's briefly look at some key hardware component. Uh, Correct a few types of the slide. Repeater boost weak signal. A hub is dumb central connection point that broadcasts data to everyone casting traffic. Then some network devices are repeater, hub, switch, router, gateway, bridge, ONO and ONT. A switch is intelligent. It sends data only to the intended device, reducing collisions. The router is connected different networks, chooses best path for data uses, router tables and NAT. Gateway connects network with different protocols, supports protocols transmission complex and costly. Bridge connects similar LAN networks, not for different protocols. ONO and ONT converts fiber optics signals used in a FTTP, essential for modern high-speed internet. So we can see the network topology, some network topologies, repeater, hub, switch, router, gateway, bridge, and ONO and ONT. This is important for modern life. Every sector of information and technologies, we use this type of net device. So next part is network protocols. We will define what a network protocol is and explain the purpose of use some of the most common one. What is protocol? Again, a protocol is a simply a rule set for communication. It is the agree upon language that device use to talk to each other. Learning objective is define the term network protocols, explain the purpose of common network protocols, explain the use of common network protocols. Network protocols. A network consists of two or more connected devices that communicate with each other. To communicate these devices, use protocols. Protocols means a rules that defines how devices will communicate with each other. There are two types of web protocols, HTTP and HTTPS. When you browse the web, you use HTTP to request web page. The source mission HTTP encrypts that communication to protect your data from encrypted, which is vital for online banking or shopping. File transfer protocol is hypertext transfer protocol is a protocol used by a web browser to make requests to web server for a web page. If there is an error with the request, it will return a code. HTTP Hypertext Transfer Protocol. This protocol works in the same way as HTTP, but data transfer are encrypted to prevent encrypted from hacker. Find file transfer protocols is a protocol simplicity, specially designed for uploading and downloading files to and from a server. It requires a username and password for authentication and is often used by a web developer to upload website file. File transfer protocol. A web server store files a website allows to file to be uploaded to a server. It requires authentication. So file transfer protocol is um, to requires authentication. It takes authentication and access the server. FTP can also be used to download files, particularly those with the large file. So we use file transfer protocol in this way. Email protocols. POP, POP, SMTP, IMAP. These are the example of email protocols. Email relies on suite of protocols. SMTP is used for sending mails. POP, POP is used for receiving mail by the downloading it from a server to a single device. IMAP is more advanced. It synchronizes your email across all your devices, keeping them on the server. So, email protocols are three type of email protocols: POP, SMTP, IMAP. Next is transport protocols. Transmission control protocol (TCP) enables data to be sent over the internet, server to client or vice versa. TCP does this by splitting data into packets to send. TCP is reliable because any missing packet are always present. User data programmable protocols UDP performed the same function as TCP. However, it is not reliable because any missing packet are discarded. UDP is faster for some data. Network and link protocols IP, Ethernet, Wi-Fi. Internet protocols means IP packages, IP packages made by the TCP or UDP and adds a destination for the packet's IP address. Ethernet is a family of related protocols that links the packets of data and LAN hardware. Example of Ethernet is switch, router, etc. Wi-Fi. 1. Wi-Fi is another family of related protocols that links data packets and hardware component to be used wirelessly. The office network design required devices is router, switch, PCS, and copper cables. Router must be configured with IP 192.168.1.1 using CLI. Router setup use default IP CG 192.168.0.1.1 to access setting. Login to login with default permission. Cisco network simulation essential for CNA CCNP exam preparation. Used for designing, configuring, and troubleshooting network vital. DC DHCP configuration. Workers do 4 stages discover, office request acknowledgement, requires settings, IP on router interface, DHCP pool with IP range and difficult gateway, excluded IP address. Types of NAT static NAT, manual 1 to 1 mapping, dynamic NAT, automatic 1 to 1 mapping from a pool of public IPs, helps solve IPv4 extraction by optimizing how IPs are used. So there are many types of NAT, static NAT, dynamic NAT. So thank you. And speaker note the concludes our overview of computer networks. We will cover what they are and how they are built and how they are communicated. And finally, NAT is critical technology that helps conserve the limited number of IPv4 address. Static NAT provides a one-to-one manual mapping, while dynamic NATs automatically map private address to pool of public ones. This allows many devices on LAN to share a single public IP address to access the internet. So this light we learn many types of computer networking, and thank you. And Q&A is must be available. Thank you. The completed to our computer networking, and thanks for join us and complete the computer networking. Allah Hafiz. Thank you.